Hi there, my name is Matt Marzillo. I'm a partner engineer with Snowflake, and much of my job is spent supporting integrations and patterns with Azure, specifically related to using Azure for machine learning and AI with Snowflake and Snowpark. In this video, we're going to be going through the quick start that we have that's getting started with Snowpark, Snowflake, and Azure ML. We're going to walk through preparing data for model training, actually training models, and then deploying them back to Snowflake for inference. So let's get started. Okay, you can see that we are leveraging the Getting Started with Snowpark for machine learning on Azure ML Quick Start that can be found on Snowflake's Quick Start page. I'm not going to read through the entire overview here, but I want to kind of highlight the fact that for this Quick Start, you'll need a Snowflake account, and you can spin up a free one for 30 days, and also an Azure account with access to an Azure ML workspace. Throughout the Quick Start, what we're going to be building is this architecture right here, right? And so the idea being is that from a single pane of glass being Azure ML, we're going to kind of step through the very simple 3 steps of building and deploying Azure ML models. So your step 1 is you're going to be doing some pushdown with the Snowpark data frame API to prepare your data using Snowflake Compute. And then once you have your final feature data or training set, you're going to go ahead and materialize that into Azure ML, and then very simply train a model in Azure ML. And then once we have our final model, we're going to register that model in Azure ML and then push that down as a deployment into Snowflake. Before doing this, there's a little bit of setup that we're going to walk through too, which should be fairly simple, setting up your Snowflake environment as well as your Azure ML environment. Before I dive into that, I kind of want to highlight a little bit of Snowpark for those that might be unfamiliar. So Snowpark is great, right? It's this whole new platform within Snowflake that really expands the different personas and the different capabilities of Snowflake itself. And I like to think about Snowflake as being kind of at its simple level, 2 different things, right? You have a data frame query API, which is going to allow you to write Snowpark Python, which looks and feels just like PySpark. And what it does is it translates that Snowpark Python code into SQL that gets pushed down into the Snowflake SQL engine that's existed for as long as Snowflake's been around, right? So it's this really great way of using lazy evaluation, right? So you're not actually spinning up compute every time you execute code, but you're effectively building a recipe of Snowpark Python code that will then get pushed down, and you can use that for data transformations in this lab or in this Quick Start. The second part of Snowpark is an actual Python runtime or sandbox right within your Snowflake compute, right? So you can take Python code, or think of it as a pickle file, right, and run that right within your Snowflake compute. And we're going to be showing off, this first side, we're going to be showing that off for data preparation, and the second side here, we're going to be showing that off for model deployment and inference. So, moving on in the Quick Start, the use case that we have leverages a Kaggle data that's free and publicly available. That's for predicting machine failure, right? So if you can kind of come here, if you have a Kaggle account, you can kind of come and see it has several different pieces of information on machines, right? So things like product type, air temperature, process temperature, so on and so forth, rotational speed and things like that. Additionally, what I've done is I've included some humidity data that's from the Snowflake marketplace. And we're going to show how to join these 2 different data sets together using Snowpark, and then take that and build a model to predict, let's see here, yes or no, whether or not the machine will fail. And that's how we're going to leverage this data in this lab. Okay, so the first part is really simple, right? You're gonna copy this code over, the SQL code, and set up a warehouse and a database inside of your Snowflake account, right? So if you come over to your Snowflake account, you'll just run this code here and make sure that you're using the account admin. Obviously, in the real world, you probably won't be using the account admin. For the sake of ease of use for a demo, go ahead, use the role account admin, and then create the warehouse and the database. And we're just gonna be using an extra small warehouse. No need for anything bigger than that for the sake of the demo. Should only take a couple of seconds, so go ahead and run that. And then once you complete running that, come back to the Quick Start here, and you'll set up your Azure ML environment, right? This takes a little bit more work and a little bit more time, but it's not terrible, right? So the idea is you're gonna come into your notebook screen and you're gonna create up a setup.sh file, and you're gonna copy and paste this code below, and then we'll use this here in a little bit. So go ahead and copy and paste that over, and you'll have something that looks like this right within your Azure ML workspace. Save that. And then once that's saved, what you're going to do, and this is further along in that same step of the quick start, is you're going to come over to compute, and you're going to create a new compute instance. And there's no reason for a compute cluster, just keep it with an instance. And I'll just kind of walk you through what this looks like. You'll say Snowflake. You can go ahead and use the memory optimized pre-selected compute instance. Click click next advanced settings. And then you're going to want to provision with the setup script. And then what you'll do is you'll kind of come here to browse and select that setup.sh file that we just created, right? What that's going to do is it's going to install the necessary package, notably Snowpark, that will allow us to use the Snowpark data frame API to do the data preparation that we need to do. I'm going to go ahead and leave this, but once you, I'm going to go back into that. Once you do create that compute instance, it may take about 10 minutes or so, right? So you'll click provision with setup script, select your setup script, and then once it's selected, you will click next, and then eventually create the compute instance. And I think it says on the Azure documentation 5 minutes, and in my experience, it could take a little bit longer than that. So be patient. You may want to pause this video after you create this, because it could take about 10 minutes for that to spin up. Okay, if you've paused the video, hopefully you're back. You have a compute instance that's working. You have an environment that was created with this setup script. And now what we'll do is we'll come into the Jupyter kernel, and we'll copy and paste, and we'll activate this environment, right? We're going to go ahead and activate the environment that we created with this setup script. So what you'll do is you'll first copy and paste this code, come over to the Azure ML notebook environment, click on Open Terminal, go ahead and paste that code here, and activate that environment. And then you'll come back to the quick start and then install that environment. And then once that's done, what you'll see is you'll have the ability, and that may take a couple of seconds. What you'll see is you'll have that environment, and we just named it My Environment, available to you right within your Azure ML Workspace Studio. So you can see here, this is the compute instance you just created. And then you'll have the ability to kind of come here and select My Environment. If it's not there for you immediately, you may want to refresh that kernel list. You'll see it eventually. Okay, once that's done, I feel like that's the hard part. We have our kernel and our environment up and running. The next thing we're going to do is we're going to clone the repo, right? So just go ahead and copy this code and go back into your Azure ML Studio, open up a terminal, and paste this code into the terminal. And what it'll do is it'll create a new folder here right within Azure ML. It'll be called Getting Started with Snowpark on Azure ML. And that should happen almost immediately. And then once this is available, you will move on to the next step, which is setting up the data, right? So if I kind of click back here into the quick start, you'll load the data into Snowflake. So go ahead and open up step 0, setup data, and run through these steps right here. You can see here I've left out my password, but what you'll want to do is copy and paste your account, your username, the host, include the password, and make sure you're using the role as defined in the script already. So account admin, that small warehouse you created, you're using the manufacturer database that you created, and the schema public. Go ahead and run that, and that will basically connect you to use that Snowpark data frame API. And then what we're going to do is we're going to copy over these 3 CSVs into pandas data frames right here locally in Azure ML. And these are the CSV files that you just copied over with that GitHub repo. And then write them to tables inside of Snowflake, right? And then once this is done, what you'll see, you want to double check on this, is if you come back into your environment here, is you'll see within inside of that manufacturer database in public, in tables, you'll have, those three tables that you created, right? So we created city UDF, humidity, and maintenance. And hopefully you'll see city UDF, humidity, and maintenance. And then we're going to create some other tables as we move on to the next step. Okay. So we've got the data loaded into Snowflake. Also worth mentioning is that sometimes you may get a pi arrow error. And then there is a relatively simple fix here. If you don't have pi arrow installed, you need to install it yourself. And you can kind of do that with a pip install right from the notebook within Azure ML. All right, now we're going to move on to that other notebook that we have in there, which is the _manufacturer MLflow.ipy notebook. So what we're going to do here is just literally kind of work through this file, right? The idea being is we're going to do the actual work to prepare the data, pull it into Azure ML, and then build a model and deploy it to Snowflake. So the first thing we're going to do is connect to our environment, and then we're going to go ahead and access those tables that we just created from the CSV files. But now we're actually connecting to the Snowflake tables that we have. And what we can do is look at the actual data frames too, right? So we can go ahead and call those data frames and then kind of take a peek at what they look like. And what we'll do is we have these three separate tables, right? So the one is the actual maintenance data that we have from Kaggle. The other one is the humidity file, which is just cities and the relative average humidity in those cities. And this other one is a mapping table, which shows us how to map each city to the identifier for the actual machinery. And what this does is this block of code here does a join on all of those, right? So it says, hey, let's join that maintenance DF to the humidity UDI DF. That's that kind of mapping table. And then once we have these two tables joined, let's go ahead and join that, what we call maintenance city. Let's go and join maintenance city to the humidity DF, so that now that we can actually kind of have all three data sets combined, and we're enriching that Kaggle data set with the humidity data that we pulled from Snowflake Marketplace. And an important note, this is a very simple way to use that first part of Snowpark, right? It's pushing down all those transformations and aggregations. And eventually what we'll be doing is creating a new table that's called maintenance hum right within our Snowflake environment, right? So like when we looked at that architecture when we first started off, we now have our final feature data set. And it's also important to run, this code isn't run until we actually execute this command here, right? So it's actually writing this new table and executing all this join right here when we run this. And we'll go ahead and pull that into Azure ML and take a look at what it looks like as a pandas data frame. We'll go ahead and drop a column that we don't need for model building, and then we'll set up MLflow, right? Let's use MLflow. Let's import the MLflow package. Let's define an experiment name, and we'll kind of go through a very simple machine learning pattern where we're separating in train and test. We're defining our target variable. We're defining our predictor variables, and then we'll go ahead and start an MLflow run. And then you can see here it's also worth noting that we're going to be using a really simple kind of out-of-the-box random forest classifier. We'll go ahead and fit the model, and this should all take, each block of code should take seconds to run. So I've already pre-run this, but as you're running it, it shouldn't take very long for it to execute. And then we'll kind of build some of our own model metrics, right? So you can kind of come here. We're going to take a look at accuracy and recall. Looks like we're sitting at 87.7% accuracy with a recall of 29.7%. We'll end that MLflow run. And then what we'll do is we'll go ahead and automatically get the info from that MLflow run and display some of the metrics, right? So what we'll do is we'll get the specifics on the actual random forest model that was built. And we'll take a look at some of the other performance metrics. So we'll look at like the training AUC was one, right? So it looks like we were able to kind of fit that training data really great. And then on test, obviously, we didn't do perfect, which is a good thing. But it looks like the model, is doing a pretty good job of accurately predicting machine failures. The AUC on out-of-sample data was 0.87, which is pretty good for a use case like this on demo data, of course. And the interesting thing here too, right, is as we're working through this, is that all this information is populated in Azure ML, right? So Azure ML and MLflow have that integration where as long as you track the MLflow run, it'll automatically populate the information here, right? So you can kind of come here and look at the jobs that we run, and we can see here that we ran this predictive maintenance job. You can kind of click into here, and you can say, oh, I want to, kind of peek into the actual specific information and look at some of the model metrics, right, that we already just looked at, right? So this is all populated and available within Azure ML using the MLflow and Azure ML integration that's there. Okay, so one last thing is we'll take a look at the feature importance, right? So we will produce our own feature importance plot here. This is a great way of kind of understanding how important each predictor variable is to predicting the target variable, accounting for everything that we know. The interesting thing is that this humidity variable is important, right? It looks like there is some importance for having this information from the Snowflake marketplace to predict machine failure. So that's good to know. It's worth kind of that extra step of bringing that over. And now what we'll do is we'll say, okay, we want to take that training data set and let's register it, and let's make sure we're tagging that MLflow run ID alongside of it so that we're kind of connecting that lineage from training data sets to MLflow run ID for future use. If things go haywire months down the road, we can understand we can easily get to the data set that we use for this MLflow run. And then we'll go ahead and register that model. So we're going to create a folder within Azure ML called mate and drop the model, the pickle file in there, and then register the model within Azure ML. And then the last step is we're going to deploy the model to Snowflake. And this will take a couple of seconds, but I think this really is sort of the star of the show, right? Because what you're doing is you're creating a stage, or essentially creating a folder in Snowflake right here. And then you're going to go ahead and grab that model.pickle file, and load it into that stage folder in Snowflake. And then you're going to run this code here, right? This code, it creates a user-defined function called predict failure that will allow you to use this UDF in Snowflake for any inference that you want with this model, right? So the great thing is that the UDF comes with all the flexibility and all the security as any other Snowflake UDF, and you can use it to generate inference. This code here is relatively kind of rinse and repeat, right? So as you build and deploy more models using this pattern, you can kind of take this code and you'll basically be swapping out a few different things, like the columns that will be passed to it for inference, the model name, maybe the location of the model, maybe you'll have a different staging folder for the model. But ultimately, what this UDF is doing is grabbing that model from that staging location and then running a predict prob on the DF that you're providing to it. So this should take a few seconds to deploy. And once it's deployed, you can come back into your Snowflake environment. I'll come back up here to worksheets and run this code right here, right? If I come back to the quick start, this is what this is, right? So go ahead and copy and paste this SQL call and run it here. And if I run it, okay, great. So what we did is we basically just ran the UDF predict failure on top of the data that we used to train it on. What you can see here is this is the actual predicted failure. So we're just doing a select, running the UDF, the model, the inference model on the data set, and generating a new column called predicted failure. And there you can see here we have the 0 to 1, how likely each machine is to fail within the next, I think the way the demo was set up, the next month or so. And that's it, right? So we've successfully taken some data, prepared it using Snowpark, and then built a model in Azure ML, and then pushed that model back down into Snowflake here for inference. Moving forward, there are some things that are going to be kind of evolving and getting better with this integration. The one thing I do want to point out, if I come back here to this deck, is that in this architecture, what we did, right, is we took some feature data, we brought it into Azure and materialized it as a data frame, and then registered it separately. We did that after training the data, and trained the model, and we trained the model and then pushed it down into Snowflake. The future state is that we're going to be able to automatically do that, right? We're already sitting here in 2023. Later on this year, This will all be available in GA within Azure ML. You'll be able to automatically register this data set from Snowflake in Azure ML. And that'll come with a lot of additional enhancements like lifecycle management and scheduling and things like that. It'll make for a more streamlined process for using Snowflake with Azure ML for preparing data, building models, and deploying those models. Okay, that's it. Thanks for taking the time. The quick start should hopefully kind of take you less than an hour or so to run through. It was kind of thoughtfully done to make sure it was truly a quick start. If you have any questions, make sure to reach out to your Azure or Snowflake field team, and we'll be happy to help. Take care.